So how do you like your new Nexus 7? All right, so hopefully, now that you've got a Nexus 7 to develop against, and you're ready to build Android applications using your Nexus 7, and hopefully your next step, once you've got an Android application, is design it to work with the web. And we'll talk about everything you need to know to be able to accomplish that, both working with Google's web APIs, as well as being able to take advantage of Google's cloud platform, Google App Engine, to backend your data, Android data on the cloud. So let me introduce ourselves. My name is Yaniv Inbar. I've worked at Google for about 5.5 years. I'm a senior software engineer. I'm a tech lead of the team that develops open source client libraries for Google APIs. And I'm the lead developer of the Android client library.
Hey guys, I'm Sriram. I'm the product manager in the cloud platform team. So here I'll be talking about cloud endpoints, how you can use App Engine to build great mobile backends for your Android applications.
So I'm really excited because we're going to be previewing some new technology, so stay tuned just a moment. And I'll start by talking about Google's web APIs. So about 2 years ago, I demoed, we talked about how at Google we built this whole new API infrastructure that was supposed to run all Google's new APIs. And I'm really excited that by today, I think we have something like over 30 Google APIs. It includes Google Plus and a variety of others. I'll talk a little bit about some of the ones that are available. But the good news is that we've been able to take advantage of the same API infrastructure and allow you to build your own backend for your Android application on Google App Engine. So any API that you build on App Engine will work exactly the same way. And as we said, Sriram will talk more about that, so stay tuned for that. But the goal of this session is to allow you to be able to build your Android application. First of all, to take advantage of Google's web APIs. So this is a sampling of some of the APIs that are available to you to use. Google Plus is an example. You can get a profile information about the user, their name, the email address, of course, with their permission. Maybe a list of the activities that they've done in Google Plus. Google Calendar, you're probably very familiar with that web application. There's an API interface to it. They're often JSON formatted, and it's very easy to work with. Google Drive just launched recently. That's pretty exciting. You can upload and download documents. YouTube just announced today their new API based on this API infrastructure. So I think this is pretty exciting for us. So about a year ago, I presented a session at Google I/O talking about best practices of working with Google's web APIs, and announced the beta release of the Java client library. So I'm very happy. A lot of developments have gone to that. We've added a lot more useful features. And one of the things that surprised me is that a lot of you developers were using it not just to access Google's web APIs, but really any API on the web. And that's actually was my dream. I was hoping that be able to take advantage of the same HTTP infrastructure, OAuth. These are all common web standards that any API on the web that implements it, say Twitter API, for example, you should be able to use the same library. So what we've done was actually split into 3 projects. The first project is the HTTP library. It implements the RFCs of HTTP, be able to access any resource, and really goes beyond just your basic HTTP library. It does exponential backup, a variety of other great features. And on top of that, we built the OAuth library that adds an OAuth 2.0 as well as OAuth 1.0 implementation on top of this HTTP library. Again, work with any web service that implements the specification. And finally, there's the Google API libraries. This is useful for working with Google libraries. So let's talk about some of the features in there. The HTTP library supports any Java 5 language platform, such as Android, as well as Google App Engine. We support the JSON wire format, the XML wire format, protocol buffers even. As I mentioned, the OAuth project that adds the OAuth 2.0 as well as OAuth 1.0 implementation on top of it makes it very easy to work with an OAuth service. And there's the base library that all the Google API libraries share. Implements sophisticated functionalities such as batching HTTP requests into a single HTTP request, media upload, media download. I won't be demonstrating that today, but there's lots of great documentation about how to do that. how to process errors from the Google API servers, how to reduce the size of JSON. I'll show you an example of that in a moment. And then the API, the service-specific libraries. Say you're working with Calendar or Google+. They make it incredibly easy to use. They're very simple methods, and I'll show you in just a minute what it looks like. And I'm pretty happy with how well that's evolved. We have an automated infrastructure. Every time a new API gets released, say the YouTube API got announced this morning, we simply ran the generator, and we post new libraries. And I'll show you exactly where to get them. So there's some references for you. The Google API is Getting Started webinar. We just published on YouTube. It's about 30 minutes long. It talks about all the great tools that are available, not necessarily specific to the Java library, but the APIs Console, the APIs Explorer. Really great, convenient tools. And then if you're a more advanced developer and you're trying to get the most efficient Android application possible, you want to take advantage of batching requests or partial response, partial update, this is a really great resource. There was a Google I/O session, and you're welcome to check it out. So let's talk about OAuth 2.0. And this is really it's just recently been finalized, so we're almost, all the Google APIs support OAuth 2.0 for access of protected resources. So it's really important to understand. And this is really the blocker. A lot of times when people, developers tell us, I'm getting blocked, it's usually related to authorization. So let me step you through a typical OAuth 2.0 flow. That's a picture of me. It's a little old. But that's me using an Android application. So I really want to get value out of this application. Now, we don't want just any application grabbing your protected resource from the Google service. We want to make sure there's a very strong and secure permissions model. So the Android application, what it does conceptually is it goes to Google authorization server and says, hey, I want to be able to access data on behalf of the user. So the authorization server says, well, I'm not sure. Let me ask the user, is it OK to grant permission to this application? And presumably I say, yes, of course. I'm really interested. I trust this developer. I trust this Android application. So I say yes to the auth server. The auth server returns back an access token. So this access token is much like a key that has access to data that's locked in the Google service. With that access token, every time you make an HTTP request, the Google Web API servers, you include an access token. This is in the form of an authorization header, where you simply say authorization : bearer, and then the access token. And then the Google API server has to ask the authorization server, is it OK? Is this access token valid? Has it expired? Since they often expire after an hour for the most secure application. And assuming that that's OK, we'll go back to the Android application with the data that requested. Hopefully that made sense. I'll drill down a little bit into the permission model on OAuth. Every Google API publishes a set of scopes of working with that API. Google Calendar has two of them, one for read-only access and one for editing, updating, or creating new calendars. So this is what it looks like. And I'll mention two great references for OAuth 2. The first is in the Google I/O session by Ryan Boyd, who literally wrote a book about the subject, so he can give you a great overview of OAuth 2. And as well as our general documentation. There's a bunch of different flows on there if you're interested. Now, why don't you see more applications on the web on Android using OAuth 2.0? And when I talk to a lot of developers, I get a very common complaint. It's complicated. Yes, so there's a number of reasons why it's complicated. And part of it is we just haven't done a good job of getting the message out, how to do it properly. But there's another good reason, and I'll show you the next screen of what the current authorization screen looks like. Now, if you have ice cream sandwich or a later device that represents about, I think, about 7% of the market Android devices, it would look better. But on Froyo and most of the devices in the web that you'll see on Android will look like this. And I don't know if you can see this, but is this a readable permission? Would you be able to explain to a loved one what this means and exactly what permission you're granting this application? I'm not sure. So I'll show you the next slide of what's launching really soon, and probably in the order of a couple of weeks. I'm really excited about this. It's been a long journey to get to this point, and we're almost there. So I want to see some applause if you like it. Oh, good. Yeah, so I'm really excited about this. And like I said, just a couple of weeks. Now, what I'm showing is what it looks like on Froyo. Of course, it'll look a lot better on one of these Nexus 7s. But already on Froyo, it looks very nice. I think it's pretty clear. It says it's going to manage your calendars. Great, I know what to do. I'm going to click Allow. I'm going to trust my app a little bit better now. And this is going to come with Google Play Services. And if you use Google Play Services, it comes with a really handy tool called Account Picker. It's just a little UI that shows you all the accounts that are on the device. You actually select which one you want, add an account if you want to use a different one. It's just super handy. I find it really convenient. So some of the details. Well, Google Play Services is actually an essential component of Google Play. But they've built it in a way that allows all you developers to use it. So this is really great, the way that they built it. That means that it's going to be on all users' devices, all the way down for you. I think that represents somewhere around 94% of the market of Android devices. So you can be sure that you can be able to use it. The permissions is a lot more readable. You get Account Picker. And the nice thing about it is it's more secure. It actually uses the signature, the way that you signed your application. It is able to use that, and is able to use that signature with the Google authorization server. So you never have to specify an API key, which is really easy to steal. And you can be sure that your application is the only one that's going to be able to have access to that data. It also does token caching. So these tokens expire within an hour. And it takes care of refreshing them for you. You just basically don't have to deal with expired tokens. It's really handy. It's really great. Documentation is live, but we're not yet providing you the ability to build applications in it yet. This will come in a couple of weeks, hopefully. But I'm supposed to tell you it's coming soon. We'll see, hopefully very shortly. So we're done with slides. Now we're just going to show you how to build an application. All the tools that you're going to need. I'm going to demo for you some applications, pretty simple ones, and I'll show you the code behind it. I'll show you also a few of the tools. So let's start with the tools. The first is I promised that I will show you where you can grab the Java library. So this is the open source project. And I'm just going to click on Libraries and Samples. I'm interested in a Google Calendar, so I'm going to click on the Calendar API. And there's a couple of things here that are pretty useful. You can download the library. It has the jars that you need, sources, documentation, link to the Java doc, Calendar API documentation, developer's guide, a couple other useful things, as well as I'm going to highlight Calendar Preview Android Sample. This is the source code to the sample I'm going to show you. It uses Google Play Services. You won't be able to run it yet because we haven't made it available yet. But I will show you here, just because you're attending my session. I'll give you a sneak peek of what it looks like with real code. Now I'm going to go to the APIs Explorer, a pretty handy tool. It lists all the APIs that are in Google's API infrastructure. Here I'm going to look at the list method. I'm going to first sign in using OAuth 2.0. Here are the scopes. I mentioned that earlier. I'm just going to accept all the scopes. And I'm going to execute it. Where's the execute button? Great. So this gives you a really concrete sense of what's actually going on under the hood. Here's that authorization header I mentioned earlier. And here's the JSON response. I don't know, Sriram, this is not very readable.
It's not at all.
Can I make it a little bit smaller? What do you think?
How about selecting the attributes?
Yeah. Let's use the fields editor. I'm only interested in the ID of the calendar and a summary of the calendar. That's just the title. Let's take a look. Oops. Whoops, what just happened here? Let's try that again. Click execute again. I think I forgot to click execute. There we go. It's a lot more readable. But more importantly, it also reduces the size of your HTTP response. So it is a lot more efficient. So you're welcome to play it with. This is a great tool. Next thing I'm going to do is I'm going to go to the APIs console. I'm going to start from scratch here. 1 second. OK, create a new project. This allows you to register your Android application with its signature. The first thing I have to do, and please don't forget this step, is you have to enable the API that you're interested in. There we go. I enabled Google Calendar. It may ask you to sign the terms of service. It's usually pretty standard. Create a client ID. I'll give it a name. My Android app. This is an Android application. Now you have to give it two things. The first is the package name. I'll grab that from over here, the manifest file. Oops. There we go. And the second is the SHA-1 certificate. You can read the documentation about where to get it. Here I'm using the one that comes with Android. And here's the command. Whoops. The password is Android, really secure. Don't tell anybody. Great. Let's create the client ID. I'm going to cheat here because I've already registered it, so I'm going to give it a new name. And there you go. So I wanted to show you this because this is really important. This is where you get your client ID from. You're not going to need it for the Android sample I'll show, but you'll need it for Sriram sample. I've got the redirect URI you can ignore, and the rest is the package name and the fingerprint. Now again, I won't go into the details about what this means exactly, but I just wanted to show you how it works once. In this case, I was using the debug certificate. If you're doing a release build, you want to use your release certificate as well. So you want to register that. Great. So now let's do a demo before I go into the code. Let's switch to, now the Wi-Fi has been giving me some issues, so I got it hooked up to the Ethernet. Hopefully that will work better. First, I'm going to select the account. Here's that account picker I was talking about. Going to use this account. It's going to go to the Google Auth server, and the Auth server is going to say, hey, you know what? This person hasn't given permission to the app yet, so let's give it permission. Here's that screen I showed you earlier. Going to click allow. Yeah. Go ahead and applause if you want to. All right. Now, you know what? Can you put on that screen, can you put my laptop? I'm going to sign into Google Calendar on my laptop just to show you that I'm not cheating. This is the real Google Calendar. There you go. Standard web interface. And I'm going to add a new calendar. Let's call it Google. And by the way, HTTP requests can take a long time. There we go. And it's showing up on here. Yes, it's over there. Why don't we make a copy of that? In fact, I'm going to use batch here. I'm going to make 3 copies of that calendar. And that's running in the background. There we go. OK. Let's see if I've just created a whole lot of calendars. Well, not yet. I'm not sure why that's not showing up yet. Let's delete this calendar. Why not? Let's edit this calendar. Let's give it another name. And everything is happening in the background, all asynchronously. OK. I'm not sure why that's not showing up yet, but that's all right. Cool. So that pretty simple application, just making requests, inserting calendars, deleting calendars. Let me show you the code. Now, I'm going to assume you're a fairly experienced Android programmer. You're familiar with the activities and how they work. So I'll highlight the things that I think are most interesting. The first is I made a calendar info class. In this case, I've oversimplified it a little bit. I'm just storing the title of the calendar. Obviously, you'll want a more sophisticated model. It's a plain old Java object. It's got an ID and a summary. A summary is just the title of the calendar. And I've got a calendar model class. Here I've got a map from the ID of the calendar to the calendar information and some standard add, remove, and get methods on it. So here's the activity class. Oh, let's project. Here we go. So this is the onCreate method. The first thing I'm going to highlight here is logging. This is a really handy debugging tool. It shows you the content of every HTTP request and HTTP response that you make, including the JSON content, all the HTTP headers. It's a really handy tool. The second thing I'm going to highlight here is Google account credential using OAuth 2. I'll go into that code in just a second, but I wanted to highlight the calendar scopes.calendar. That's that manager calendar scope. This is as easy as it is. If you want to store the account name, this is the currently selected account. It's a good thing to store in your shared preferences. This is the calendar client object. You pass it the HP transport and the JSON factor. And what these are, since the library has a completely pluggable HP transport, you can use HP URL connection, you can use Apache HP client. There's lots of great information about which one to use and which Android SDK level. And also for the JSON library, that's completely pluggable as well. If you want to use Jackson or JSON, or on Honeycomb, there's actually a built-in JSON parser, so you can use that as well. And finally, you pass it the OAuth 2 credential. Now let's go to Google account credential. This is where it gets more interesting. The first method that's interesting is using OAuth 2. Now in this case, you pass it an array of scopes. Maybe you get a scope for both calendar and blogger. So every this access token that you have enables access to both of those APIs. The other use case is using audience. And Sriram is going to explain to you what that's about. That's when using Google Cloud Endpoints. The next thing here that's interesting is the initializer. Every time I make a request, I want to use exponential backoff. It's a one-liner to add that. Next thing is, this is my favorite. It shows you how to use the account picker. You just pass it mostly null parameters to it, and you get a very good default behavior. It is the one that shows the screen that allows you to select which account you want, and it gives you back an intent. You just start that intent, comes back with the access token. That's pretty much all you need to know is when you're programming it. That's how easy that is. Next, getting a token. A Google Auth util, as well as account picker, again, that comes as part of Google Play Services. The get token method just returns a string based on the scopes that you give it. What's interesting about this method is how we handle errors. One type of error is transient auth exception. That just means there is a connection problem or it can't reach the server for whatever reason. The best strategy for that is to retry the request and using an exponential backoff policy, as I've done here, just to make sure not to overload the server. Fairly straightforward. You just copy this code, it'll work. Any other kind of auth exception, I'm just going to wrap in an IO exception to handle it somewhere else. I'll show you that in a minute. The next one is the actual request initializer. This gives it the bearer token for the authorization header. I mentioned that earlier. And the second thing it does is if I get a 401 HTTP error code, this is the standard way of saying your access token has expired. It's no longer valid for whatever reason. So what we have to do is we have to tell Google Play Services to remove it from its cache. So the next time you make a request, and this is just going to automatically retry it, it's going to get a new access token from the server. That's all there is to it. Now, there's a lot of code in here. Hopefully, I can get this into a form of a Java library. You can just use Google Account Credential directly. That's something we can maybe do in the future based on your feedback. I'm going to show you the async task. Now, if you're an experienced programmer, you're probably familiar with async task. Any long-running operation, you definitely want to run in a background thread. You never want to run that in a UI thread. So that's what I'm using here. This does some standard progress bar stuff. But doing background, this is my abstract class that all my async task classes extend. So you do the HTTP request in the background, and then you catch user recoverable auth exception. That's what tells you, hey, you need to show the permission screen, that really nice permission screen that I think most of you liked. So it's 2 lines of code. You get the intent from that, and you start activity for result. Good. So let's show you an example of getting let's load calendars. This is how easy the Google library is, and I've gotten feedback about this. This is just too easy. It should be more than a line of code. So this is a library. You just call calendar.calendarlist.list.execute. The one thing that I've done here is I've actually gave it a partial syntax saying I only want the ID in a summary. That's exactly what I did in APIs Explorer. A good practice in general. It gives you a plain old Java object, calendar list. You get the items, and you update your model. As simple as that. Now let me show you how simple batching is with the library. In this case, you have to create a batch request object. that just stores a collection of requests to make, which when you execute will then execute all those requests. You have to register a callback method for each request. In this case, I'm inserting calendars. The onSuccess method just updates my model. On failure, will show an error. Let's see, what else is interesting here is Proguard configuration. So I wanted to show you, I get a lot of feedback, hey, this is all great, but it's a really big library. And oftentimes when you're debugging, it'll look like a 4 megabyte application. Well, the trick is to use Proguard. And this is really important. So I want to show you how large the application is if you're using Proguard. So let me go into settings. Oops. Apps. I don't know if you can see this, but it says here, 332 kilobytes. This is a much smaller library. So the reason is Proguard basically strips out everything you don't use. It's absolutely essential if you're going to release a real application to the market. You'll want to do that. You want to minimize the amount of space you take up on your device. Great. And it's as easy as using the Proguard configuration that Eclipse gives you. There's a properties file here. You just uncomment the Proguard config line, and you want to use, and there's a couple of things that you add to the Proguard configuration file. I'll give you in a documentation. All right, so let's get back to the slides, and I'm going to let Sriram tell us all about Google Cloud Endpoints.
Awesome. That's a lot of content. You guys want a break? Just kidding. All right, let's talk about Google Cloud Endpoints. So show of hands, how many of you are App Engine developers out there? All right, around 10%, not many. How many of you are Android developers who have used a mobile backend of some sort? All right, that's a fair amount of you. So my aim at the end of this talk is to ask all of you, or rather to get all of you to sign up for the Trusted Tester program for Google Cloud Endpoints, right? So let me quickly show you how I'm going to do that, right? So what is Google Cloud Endpoints all about? So Google Cloud Endpoints is the ability to easily develop code on a mobile backend, that's App Engine, and consume it across multiple platforms, Android being one of them. You can consume it from an iOS platform. You can also consume it from any browser out there. So what is so cool about App Engine, right? App Engine automatically scales according to the incoming load. So you don't have to worry about provisioning servers. You don't have to worry about configuring them, keeping them updated with patches. And where does App Engine store all its data? It's got a variety of options. It's got a NoSQL, highly scalable data store, which you can use to store your data. If you're not a NoSQL junkie, if you're a SQL junkie, you can also use Cloud SQL, right? So the App Engine app that you write your backend in can make use of the same web APIs that Yaniv just showed. And all the functionality in your backend can be exposed using a simple REST interface, which we call as endpoints, and can be consumed using the same Java client library that's used to consume Google APIs. So that means that you essentially get to develop APIs on Google API infrastructure that powers your Google Plus API, Gmail API, and all that stuff. And along with that, you get all the good functionalities, tooling, the API Explorer to explore your own APIs. And you also have inbuilt Google plugin for Eclipse support for actually producing these APIs and consuming these APIs. So in fact, Google plugin for Eclipse version 3.0 with support for cloud endpoints has been released today. So I guess you guys should go ahead and download that.
All right.
All right, so you might have attended a talk on Google Cloud Messaging for Android. So it's come out of preview. And I'm happy to announce that Cloud Endpoints also has pretty good support for cloud messaging. So essentially, what do you want to do here, right? You want to store state in the cloud. So if you want to store state in the cloud, you also want to get it synchronized across multiple devices. And how do you go about doing this? There are a couple of ways in which you can go about doing this. One obvious way is to kind of implement some kind of a polling logic in which you poll the server every now and then. But that's going to suck out your battery. It's going to be really bad for as far as your network bandwidth is concerned. So what is the solution here? So Google Cloud Messaging works well with cloud endpoints in that when you define an endpoint which modifies the state of your data, you can use Google Cloud Messaging to send a ping back to all registered devices so that the required devices actually get the data back. So this really works well for a case where you want to synchronize data across multiple devices. So I'll be showing a cool demo which demonstrates this. All right, so the use cases that we spoke about was that you can use App Engine to centrally write your business logic, perform some kind of computation in case you're writing a chess game. Suppose you want to compute the next best possible move, that can be done on App Engine. If you want to store the state of your chessboard, you can do that using the data store. And you can synchronize state across multiple devices using a combination of endpoints and Google Cloud Messaging. Right, so I want you to do this. Go sign up on endpoints-trusted-tester.appspot.com. So it's a trusted tester program. It's possibly got some rough edges, so we really want your feedback here. So give it a shot. All right, so time to get our hands dirty with a demo. So what am I going to show you? I'm going to show you a simple application. If you remember this UI, this is similar to the UI that Yaniv just showed you for his calendar app. So it's called Cloud Notes, the ability to store your notes in the cloud and carry it on your various devices that you have. So the UI is really simple. It's got an add note functionality. So here I can say, what do I want to do? I want to build a rocket. How about that? So what's happening now is, the rocket, build a rocket note is actually being sent over on the wire in JSON format to App Engine, and it's securely stored in the cloud for you, right? So that's cool. Let's just write another node to make things more interesting. Let's take it to the moon. And what do we do there? Let's go build maps for the moon. We are Google here, so we build maps everywhere. So just to make sure that I'm not storing it anywhere else, App Engine provides a cool interface for administration that's available both locally as well as on your App Engine remote endpoint. So here I'm actually using a local development server that's like a local version of App Engine running for your testing. So I'm going to show you the data that's actually stored in the cloud. Right. So you see a entity kind here, which is note. I'm using the NoSQL data store. I'm storing my notes in a note object. So if I do a list entities over there, you should be able to see that the two notes that I built, build a rocket and take it to the moon, are right there. And they are automatically tied to my email address, which means that I've already authenticated using the same OAuth stuff that Yaniv just showed you. Right? So storing stuff on your cloud and getting it from one device is fine, but it's not cool enough. What do you think?
You know what I think would be really cool?
Yeah?
If you could show 2 devices.
Awesome. Let's do that. So how about that? Let's take another device. OK, so the other device automatically has the state. I didn't have to do anything. So let's give another demo of. So OK, you go to the moon. Let's go and hang out in the moon. Not literally, actually using Google Hangout.
Sergey's
right?
next project.
So once I click on save, what should happen is that this note should go to App Engine, right? And App Engine will use Google Cloud Messaging to actually ping all devices which are registered for this particular user, which is registered. The user is srsaroop@gmail.com that you saw. So hands in my mouth, I'm going to try this. Let's hit on save. How about that?
Yeah.
Right. Okay, let's do a couple of other things, right? How about an edit? Is that going to still work? Let's not build maps. Let's build glasses. OK, I'm going to delete the whole thing.
Perfect. Let's see it.
OK, the emulator is not very responsive. OK, let's give it one more shot. Let's click on edit. All right.
Just click save.
Let's build glasses. OK, what's going to happen now? All right, there you go. All right, so this is an example of an application that shows you how to use Google Cloud Endpoint and get automatic state synchronization using Google Cloud Messaging. So I'm going to be a little adventurous now, and I'm actually going to show you how to build this application from scratch. So let's go about doing that. And I'm a product manager. If I can build this application, I'm sure all of you engineers can do that. Right. So I'm going to start with building a simple Android project.
Where did you get this tool?
All right, where did I get this tool? So a couple of things you need to note here. So the first thing is that I've installed the Google plugin for Eclipse, which is a simple utility to easily help you develop using App Engine. You can do a one-click deploy to App Engine. The font might be a little small for the guys in the back. So I'll show that to you in a minute. So I've essentially installed Google plugin for Eclipse and your favorite Android development tools. And these two plugins really work well together. Right? So let's go ahead. Let's call it Cloud Notes Z1. All right, I'll go with the defaults here. Let's give it a package name. Let's call it Cloud Notes. I don't need an activity. I'm going to build my own. Let's hit on finish. All right, so this is like a simple Android project. And you're like thinking, how do I generate like a backend for it? Is that going to be difficult? Now, just look at this. If I right-click this Android project, under the Google menu, you see there is this option called Generate App Engine Backend. It's as simple as that. All you have to do is click on it. So what's happening is we are downloading a bunch of libraries that's going to help you build APIs on App Engine. And it's automatically set in your class path. And not only that, there are libraries for Google Cloud Messaging, which is also downloaded. And there's a library to actually register your device with App Engine that's also downloaded. So all that is done for you, right? So you essentially have two projects, one an Android project and one the corresponding App Engine backend for it. So what's the next step? The next step is to define APIs that you can call from the Android app, right? So what do you define APIs on? You need to define it on some kind of a resource. So in my case, the resource is just a note class. So as you might have guessed, a note is nothing but a simple, plain Java object, a POJO. So I'm going to just copy over some code. Let's look at this. All right, so the node class is nothing but ID, which is like a unique field. I've marked it with a @ID annotation, which essentially says that it's a unique identifier for this particular object. @entity is a standard Java persistence API annotation to say that this object is going to be persisted. Description and email address are just fields with setters and getters. Now, how do I go about creating APIs that actually create a node, delete a node, list nodes, all the functionality that you see? Again, our aim is to reduce the amount of code that you have to write on App Engine. Google plugin for Eclipse acts like a good friend and allows you to do a one-click generate cloud endpoint class. How about that? So all your code is pre-generated, right? So you have the list node method, which actually uses the Java persistence API to persist your nodes to the data store, App Engine data store. So all this code is pre-generated for you. It should just work out of the box. There's list node, there's get node, insert node, update node, and remove node. In addition to all this code, what you should notice is the small annotation on the top. It's the @API annotation, which essentially says that this is an endpoint that I want to be exposed as a REST API, right? That's the only annotation that you need to add. You can modify this class. You can add other functionality. For example, if you want to search node by some kind of a substring, you can add that. And in which case, you will have to annotate each of the methods with an @API method annotation. You can read up that in the docs. But in the default case, this should just work out of the box. So one thing that's missing in this code is the concept of authentication and a user, right? So list node in this case is just selecting nodes from the App Engine data store. It doesn't really select nodes that correspond to a particular user. So how do I add the notion of authentication, right? So it's, again, really simple. So I've just made the modifications, and I'm just going to copy over the modified node endpoint. So I'll show you what needs to be done here, right? So if you notice in the @API annotation, I'm adding two other parameters. One is a client ID that should be very familiar. Yaniv just generated that from the API console. So you just need to copy that string out that Yaniv generated, copy it there. The audience is just to make sure that the request is coming from the correct server. So it's just the application identifier that you can get when you register with App Engine. So those are the two parameters that you need to put. And after that, life is simple, right? So what you need to do is to add a parameter called user. So user is defined by the App Engine SDK. And this user object is automatically filled in by App Engine when a valid request comes into App Engine. So when a valid request with the access token that Yaniv spoke about comes into App Engine is able to validate that and is able to convert that to the user object that comes in nicely to your APIs. Right? So you don't really have to pass this user object. It's created by App Engine for you. So, and then it's just a matter of changing your code a little bit to make sure that you're fetching the nodes for a particular email address. The user object has an email address field, so you can use that to achieve that. So similarly, I modify all the other methods. Get node, I add a user parameter and make the necessary checks. So all that stuff should be self-explanatory.
Can you show me a little bit what it looks like in the Android application?
Sure. Before I do that, one thing that I didn't talk about in App Engine is the ability to actually ping devices when the state of a node changes, right? How do I do that? Is that going to be difficult? Not at all. So device ping is a class that's generated by the Google plugin for Eclipse. And device ping has a method called ping all devices. All you need to do is to call ping all devices, and all devices registered with App Engine will automatically be sent a ping. Right? So let me just copy over one more class, and then we should be able to go to the Android piece. All right. So like I said, whenever the state of the resource changes, in this case, note. So for example, when I do an insert note, I just have to call device ping.ping all devices, and that should send the C2DM ping. So let's go on to the Android app. So I'm not going to show you the standard stuff of Android in terms of UI development and all that. I'll just show you the pieces where I need to call the endpoints. So I'll copy over a bunch of resources that's needed for my app. OK, let's get this main.xml out of the way. I don't need it. And I'll copy a bunch of classes. I'll quickly go through them. And then copy the manifest, which defines the activities that I have. The last thing I need to copy is this Google Play Services to jar. So it's the jar which allows you to have that awesome authorization screen that Yaniv showed you. Unfortunately, it's not part of the Android SDK yet. It will soon be, so in which case you don't have to do this. All right, so let's look at the classes that have been generated. OK, so it's showing me a bunch of errors. So let's be adventurous and see what those errors are. Right? So it's essentially saying that it's not able to find out what this com.appspot stuff is. So one thing that I forgot to do is to actually generate a strongly typed client library for my API. Right? So Yaniv showed you how you can use a Java client library, how you can go to the website and download the APIs for various libraries. Now, how do you do the same for the APIs that you develop? Not a problem at all. So right-click your App Engine project, Google generate cloud endpoint client library. So if things work, that client library should automatically be generated, copied down to your Android project, and there you go. The compiler errors are gone. Right? So if you see the libs folder, all the client libraries, including the awesome Java client library with all the OAuth libraries, are copied over, set in your class path. In addition to that, you also have classes that you can call into. So I'll show you in a minute how that's done. So an example of an async task that I'm going to show you here is async edit note, which is actually the class to edit a note. And if you notice, the code is really just one line. I just get a object called endpoint. I construct it in a very similar way as I would for any other Google API. And I just call the method that you want to call. In this case, it's update note, and I pass in the note object. It's as simple as that, right? So all that stuff is fine. Now, do we have time to actually run this app? I think we do. So let's give it a shot and
So what you're doing here is you're actually running it locally. So there's
Yeah.
a local App Engine instance.
That's right. So I'm running stuff locally here. When you're developing with the cloud, you want the ability to test stuff locally before you can actually deploy it. So let me show you how I'm doing that here. So just click on the project, click on the Run button, and App Engine should start up locally for you. Let's give it a while. The network here is not very good. All right, it started. So let's quickly deploy the Android app. It's not just the network. My laptop is also slow. Can't blame the network for everything. All right, but I think you guys should trust that it works. Let's have a quick shot at that.
I have to say, this is pretty amazing. 10 minutes to build an Android app like that.
Yeah. But I had a lot of code written already. All right, cross your fingers. So this is the new app. It just come out there. So the spinning wheel indicates that it's making a call to get all the notes. Obviously, there are no notes because it's a brand new app. So let's chill out since it's end of the day. You guys want to go home. All right, chill out. Goes in. And just to make sure that I'm not bluffing you guys, let's go ahead and click on List Notes. And there you see, chill out there.
All right.
All right, let's switch to
Great. So you probably want to get some more information about some more information about Google Cloud Endpoints. There's a great link here. Tells you all about the back-end part of building mobile apps, as well as covering iOS and web applications. Google Cloud Endpoints support all of those. And in fact, we have the same generation service to provide strongly typed libraries for iOS, Objective-C, and JavaScript dynamically. Yeah. And another great I/O session about how to do it with the HTML5. So I'm pretty excited about this, and I hope you are too. I highly encourage you to go to the Trusted Tester place to request a Trusted Tester. I can show you that link real quick.
Yeah.
Right there, Endpoints, Trusted Tester, appspot.com. Go there. As well, if you're interested in how to build with Google Web APIs, that your next step should be to go to the Code Lab. So we actually have 2 great Code Labs for you tomorrow. The first is how to build REST APIs for mobile. Well, I think there's a great tic-tac-toe sample that you can build, a very simple one. And I hope that gives you confidence of working with Google Cloud Endpoints. And as well, that's at 11 o'clock. And I'll be there at 1:15 for the Code Lab on working with web APIs. I'll step you through the auth flow. I'm sorry I'm not going to be able to show you Google Play services, but I'll show you the standard account manager flow. It does work really great with, or at least fairly well with your new Nexus 7 device to bring out with you. And I'll be there to answer any questions. And before we jump into questions, I just want to make one request from everybody here. If you like the session, please grab one of those +1 cards and put them in a box. And I really appreciate it.
And we have a bunch of stickers, Cloud Endpoints, so come here and collect those. Can you go to the mic, please?
Yeah, please go line up next to the mic if you have any questions for us. If there's not enough time, please feel free to come by. We'll just stick around. Happy to answer any questions you might have. So go ahead.
Yeah, I was wondering if these are great presentation, by the way. But I was wondering if any of these tools and plugins are going to be available for IntelliJ or other IDEs.
So it's not currently available, but we do have other means of like generating a cloud endpoint. For example, we provide a script that you can just call on the command line. So currently, we do not have IDE support other than Eclipse.
Okay, yeah, because seriously, Eclipse sucks.
Yeah, that's a great question. So like he said,
we can have a debate on
that. So one of the cool steps that he showed you is generating the client library. That's actually done in the cloud. We actually have a service that does it. So in theory, it should be really easy to build IntelliJ integration because it's just a cloud service that you can call.
So I'm actually working on essentially
endpoints.
a weather app.
Oh yeah,
And
sure.
all I'm trying to do is synchronize some really simple settings, like units, location, stuff like that. I came across the backup API, which I know isn't supposed to be used for synchronization, so that's kind of what I wanted to ask about, because having to go maintain a server and do all of that work just to do something that simple, it seems like App Engine is really designed more for applications which almost revolve around.
Yeah. So as an example, I showed you, how to achieve state synchronization. But one thing that I did not show you is, how do you actually store the state locally and, get it automatically synchronized with the cloud. So just wait for a few weeks. We are coming up with an awesome technology that's going to allow you to synchronize shared preferences, which is the standard way of storing settings on Android, across multiple devices using App Engine as a backend. Right? So that's going to come out of the box for you that you can just use, and that stuff should just work.
That's exactly what I need.
Awesome.
Thank you.
Thanks for asking.
Yeah. Thanks for asking. I almost forgot about that.
All right, so I have a question about the authorization part.
Yeah.
Like you said, it's going to be handled by the yet to be released Google Play, I don't know, plugin or whatever.
Yeah.
So does this mean that the account manager stuff is being deprecated, or?
Great question. So is the account manager stuff being deprecated? And I probably shouldn't answer that question just because I'm not the person who owns that part of the code, so I don't know what their plans are. But essentially, yes. I mean, if not literally deprecated.
Essentially, yes.
We want you to switch to using Google Play services, definitely, as soon as it comes out.
So it will be like updated automatically along with the Play client, or?
So it is actually an essential part of Google Play. And the beautiful thing that they've done is rather than just building it for Google Play, they've opened up for developers for anyone to use, which is just fantastic. So because it's an essential part of Google Play, it will be a market update for everybody's device, for you and higher.
Because up till now, you have to wait for the next Android iteration to get the Google services and account manager and whatever.
So I want to make this clear. It's not just part of Jelly Bean. It's because it's an independent component. It's not part of the operating system. It's just going to be a market update. You'll get a new application. And so that's the APK. And as well, they will also publish a jar file, which you include in your Android application.
Okay,
that makes it very easy to use that service.
Thanks.
Hi. Do you have any examples of using access control lists and things like that? Say, for instance, that note, you want a whole group to be able to edit that note and where things would fit in?
So we don't right now, so maybe we could discuss a bit more to understand what you're talking about.
Can you repeat the question, please?
Talking about access control lists to endpoints and data, and who manages that? Whereabouts is that managed?
Oh, that's a great question. How do you set up access control list for that data? So let's follow up on that. We'd like to find out more about what your use case is. I mean, obviously you can build anything, right? It's a app engine, but that's a great question how to make that easier.
I had a question about the account manager. You said that for using like basically Play services, you'll be using, what was that, account picker?
Yes.
Does that mean I need a Google account or a Gmail account to use Play services?
Okay, yes, that's a good question. So what I've done, so actually I don't think there is that restriction necessarily. However, as part of the Google Play Services tools. However, because it will only work with Google's web APIs, it will not work with any OAuth 2 server. It has to be a Google account. Now, it doesn't have to be a Gmail address. It can be even a Yahoo account. As long as you set up a Google account for that email address, it should work.
Gotcha. Okay, thanks.
Is there a way to use the OAuth and the API infrastructure without going through App Engine, like if it's your own server?
So it's currently not available, but that's an awesome idea, and we are looking into it.
Cool.
Yeah. Build your API on a different kind of server. So as we said, we built this API infrastructure. In theory, you could do you could build any kind of service on top of it, but coming up with the with the underlying infrastructure of connecting that Google Cloud with that API infrastructure makes a lot more sense when it's all part of the Google Cloud platform.
You still hear me? Yeah. If you're looking to create an API system for your corporation or whatever, Is there anything else you'd recommend, out there besides this? Obviously, can't use it yet.
Sign up for Cloud Endpoints. Check it out, man.
Okay, give it a shot.
All right, so we're close to wrapping up. So thanks a lot, guys.